Integer operations or working with positive and negative numbers. By integers, we mean our whole numbers, 0, 1, 2, 3, and their opposites, -1, -2, -3. In earlier math classes, we used some really great visual models to add and subtract integers in particular. We used integer chips and we used number lines. However, the expectation in Algebra 1 is that you're able to quickly and without a visual model add, subtract, multiply, and divide integers. You need to be able to do so without a calculator. We're going to go ahead and quickly review some strategies for doing so, starting with addition. If you are adding together two integers, you need to look at the sign of those two integers, meaning whether they're positive or negative. If both of the original numbers have the same sign, meaning both integers are positive or both integers are negative, you're going to add the two numbers together. Then you get the sign of your final answer from the sign of the original numbers. Here's an example of that, 3 plus 5. We have a positive plus a positive. Another example that falls into this category is -3 plus -5. Both of the original integers are negative. Hopefully this first computation is super easy for you. 3 plus 5 is just 8. Add them together. And then my final answer is positive because my original two numbers were both positive. Second example, -3 plus -5. I still add the 3 and 5 together. I get 8. And then my final answer is negative because both of my two original integers were negative. Next category, if I am adding together two integers and they have different signs, meaning one positive and one negative, then I'm going to subtract the numbers. Here's an example of that, a -3 plus +5, or +3 plus -5. Now in the case of -3 plus 5, I subtract 5 minus 3, which is +2. But then I get my final sign from the sign of the bigger number. So by bigger in quotations, I mean bigger in absolute value. So ignoring this negative, 5 is bigger than 3, and so my final answer is positive because the 5 is the bigger number and it's positive. In the second example, 3 plus -5, I still subtract. 5 minus 3 is 2. But now I get my final sign from the bigger number, which is this 5. This -5 is negative. So again, I look at my original two numbers. I ignore the negative. That's another way of saying I think about them in absolute value, and I see which is bigger. 5 is bigger than 3. I get the sign of my final answer from that bigger number, -5. Next, let's go ahead and look at subtraction. So when we're subtracting, it may be helpful to change the subtraction problem into an addition problem by adding the opposite. Adding the opposite. If we subtract a positive, this means we're adding a negative. If we're subtracting a negative, this means we're adding a positive. Let's go ahead and look at each of these examples. So 3 minus 5 is an example of subtracting a positive, subtracting +5. So we can change this into this addition problem, 3 plus -5. Now we've already done this problem above. 3 plus -5 is just -2. I subtracted 5 minus 3, which is 2. And then my final answer is negative since that bigger number 5 is negative. Next example, -3 minus -5. Now here I'm subtracting a negative. Subtracting a negative is the same as adding a positive. So -3 minus -5 becomes -3 plus +5. Again, I've already performed this operation above. -3 plus 5 is just +2. Having subtracted 5 and 3, 2, and then my bigger number is positive, leaving me with a final answer of +2. Next case, -3 minus 5. Here, subtracting a negative, or subtracting a positive, subtracting +5, is the same as adding a negative, adding -5. So -3 plus -5, I'm adding two numbers with the same sign. So I add them together, 3 plus 5 is 8, and then my final answer is just -8. Last example, subtracting a negative again, 3 minus -5. The addition problem here is much easier. Subtracting -5 is the same as adding +5. So 3 minus negative 5 is the same as the addition problem 3 plus 5, and 3 plus 5 is just 8.